anybody really objects to. I mean, you're not really on the camera, I think, like very much anyways, but you know, I just want to let you know that it is recording. So you want to say hi to Grace? Everybody unmute. Say hi, Grace.
Hi, Grace.
Grace.
Hi, Grace.
Okay, good. All right. So objectives and practice problems are in the lessons folder. And objective number 1, which is as far as we will possibly get, even if we get that far today, is a new thing that we're going to learn. It's called a T distribution. And we're going to talk about why we're going to use that rather than the normal or the Z distribution. You know, we're all familiar with Z-scores. We've been talking about it almost all year. Yeah, now we're going to learn about T-scores, and it's actually quite interesting as to why we have to use T-scores instead of Z-scores when we're doing inference confidence intervals for means, for quantitative variables. All right, then we're going to talk about critical values from T-distribution. We're going to talk about confidence intervals for a population mean. We're going to talk about sample size and sample variability on a confidence interval. And this last objective here, we're going to identify a common misconception that a confidence interval estimates individual values rather than a population mean. So again, this is the one that we're going to be doing really today. Here are practice problems that you'll have to do, you know, as we kind of proceed, you know, continue on with this. But a lot of this stuff here should sound really familiar. Some of the questions we can answer. Oh, this is a good one. If there's a big stack of M&Ms put in front of you, how many are you likely to grab? How many hours did the average student at your school sleep last night? That's an interesting question. Answer that with statistics. How much weight does a typical college student carry in his or her backpack? And that would be interesting to compare from, say, like this year to like 10 or 15 years ago, you know, with the advent of ebooks and, you know, that. Okay, so we're going to learn how to construct confidence intervals to determine these things. And like I was saying a minute ago, in topic 16, we looked at confidence intervals for a population proportion. But in this topic, we're turning from binary categorical variables. We're looking now at quantitative variables. So instead of proportion, we're going to be dealing with the mean of that variable. And like I said, we're going to do this thing with a T distribution and figure out, well, why do we need to do that instead of a Z-score? So we need a little participation here. Oh, you know what? Can you guys annotate this? I shared the screen. Can you go up to the top and annotate? Can you do that? No, it's not giving you the option to annotate. Well, that kind of sucks. Why not? I'm sharing my screen.
No, yeah, you could do it.
You can?
Yeah.
Oh, yeah, you're doing it. Yeah, who's doing that?
Oh, I did some of it. Or like just the little weird green lines.
Yeah, okay. All right. So if you would erase the little green lines, can you do that?
Don't erase my bubble.
Where's your bubble? The one on 7?
No, the one between 5 and 6.
But this one we can erase? No, I can't erase it. You got to erase it. Or maybe somebody else did it. No? All right. So we have a dot plot here. Use your annotation and as best you can, and make guesses for the average amount of sleep that a student in, let's say, in your class, in the senior class, got last night. So just do that one first. The average amount of sleep that a student in your class got last night. Oh, how interesting. So I got 5, 10, 15. There's still are several who have not joined our little dot plot here.
Mine isn't working, Mr. Jenkins.
Yours isn't working?
No.
Huh, okay. Anybody else want to chime in here? So this is average. And let's see here. Let's clone this here. How am I going to do that? I should have done it before. Let's see what happens here. So let's do this. It's not working on your colors. How interesting. Okay, well, we're learning something every day. All right, we'll just leave it at that. We'll leave it at that. All right, we'll come back to that. Oh, wait, now I think I guess you have to erase it all. Can you erase them? Here I thought that was just going to be on that one slide. And I don't want to be looking at the dot plot the whole time here. Got 2 more, black, brown, and can anybody erase those? No? 1, 2, all right. So maybe I'll do this one here. Okay, so I need an interval that you believe with 90% confidence includes the average amount of sleep that a student at your in your class got last night. So again, we're talking about the senior class, all your buddies, right? I need an interval that you believe with 90% certainty includes the mean amount of sleep that the students got last night.
4 to 8.
So I see 4 to 8. Anybody want to volunteer something different?
Maybe 2 to 9.
2 to 9. That 90% confidence there? 2
Yes.
to 9. Okay. Anybody else want to throw something in there? No? Okay. So then who gave me 4 to 8?
Hi, me, Yvette.
Yvette, okay. What about 99% confidence?
2 to 10.
So you're comfortable 2 to 10 with 99% confidence. And Evelyn, what about you?
Maybe 0 to 10.
0 to 10. Well, boy, I would have 99% confidence in that one for sure. Yeah, good. All right. So this should come as no surprise. Which of these 2 intervals is wider, the 99 or the 90?
99.
Why?
Because it's bigger.
Well, that's true. It is. It is. Okay. So can you kind of put in words like why that makes sense that it would be
Because
larger?
you're more confident. So
More-
you have to have a greater range of which the actual value can lie.
Yeah, I think that makes some sense, right? I mean, you know, and we talked about this when we were dealing with proportions as well. You know, if I went from 0 to infinity, if actually in this case here, I would just have to go 0 to 24, right? Because you can't sleep more than 24 hours in a day, right? I would be 100% confidence that the amount of sleep was somewhere between 0 and 24. You know, so the wider the interval, the more confident I am that it includes the actual mean. All right. Well, here we go. We're going to record the data right now. So, so I'm writing this down here. Isla, when did you go to bed and when did you wake up? Are you there, Isla? Oh, maybe Isla's the one that I was missing, huh? Clara's here. No Isla? Okay. Okay, Allison, when did you go to bed? When did you wake up?
I went to bed at like 12:30.
When did you wake up?
I woke up at 7:40.
7:40. Okay, Allison. Oh no, Allison, I just did you. I'm the reader. Alyssa. Alyssa, are you there, Alyssa?
Oh, yes, I'm here.
Yeah. When did you when did you go to bed and when did you wake up?
I went to bed at 11:30
Uh-huh.
and I woke up at 8.
Oh boy, right, you cutting it pretty close there, huh? Okay. Ariel, how about you?
I went to bed at like 10:30 and I woke up at like 6:30.
Okay. Sitlali.
I fell asleep at 11:15.
Uh-huh.
Woke up 7:09.
7:09. Very precise. Clara. Yeah, okay, good. Yeah.
I went to bed at well, I'll do 2 nights ago because I had a weird sleep last night. I went to
Okay.
bed at I think like 12:30 and woke up at like probably like 8.
Okay. Emma.
I went to bed at like 11:30 and woke up at like 7:30.
Okay. Evelyn.
Um, I went to bed at 4:17 and I woke up at 7:40.
You said 4:17?
Yes.
Oh boy. Okay.
Yeah.
Is everything okay?
Well, just thinking about things.
Oh, okay. Giselle, how about you?
I fell asleep at 1:30 and woke up at 7:55.
Okay. Grace is not here. Isabella Andrade.
I went to sleep at 2 and I woke up at 7:50.
7:50.
Yes.
And Izzy.
I went to bed at 3:13 and I woke up at 7:45.
And Cassandra.
I went to bed at 11:55 and woke up at 7:30.
Kaylin.
I went to bed at 3:30 and woke up at 7:50.
7:50. Keely. Keely, are you here? Yeah, you're here. We'll come back to you. Lily. Are you there, Keely? Good. What time?
Yeah, I went to bed at 2 and I woke up at 5.
Oh my goodness. Okay, Lily.
I went to bed at 1 and woke up at 7:45.
Maddie.
I went to bed at 11:30 and woke up at 7.
Natalia.
I woke up, or I went to bed at like 12:30, woke up like 7:50.
Rosemary.
I went to bed at 11:50 and woke up at 7:45.
Tati.
I went to bed around like 1:30 and woke up around 7:45.
And Yvette.
I went to bed maybe around 12, woke up at 5:30, and then went back to sleep around like 6 to 7, something like that.
Okay, so
Don't
we'll
really
just make
know.
that 6:30, so give you that extra hour there. Okay, Bella.
I slept at 1:30. I woke up at 8.
And Annie.
I went to bed at 12:30 and woke up at 7:30.
Sasha.
Sorry, I was trying to unmute. I went to bed at 1:30 and I woke up at about 7:50.
And Virginia.
I went to sleep around 1 and woke up at 7:30.
Wow, how interesting. Wow. Okay. We'll use that as data as we go forward in this chapter here. But yeah, I went to bed at 8:30. You know, so you guys are like you're like really late for me. Well, when I was in college, I would my schedule in college was 2:30 to 8:30. So 6 hours of sleep. That was my deal. 2:30 to 8:30. But not anymore. Nope. 8 o'clock. Okay, that's good. That's good data. Well, I'll work out the hours on that and we'll play with that later. Okay, so I want to tell you we're going to see some very familiar symbols in this chapter, but we need to remember what each of them mean. So let's play with the magic bowl and see if we can remember what they mean. So I'm going to go from 1 to 25. So we get to start with Maddie. Okay, what does come on, here we go. What does that mean?
Is it the critical error?
And you see what I circled here, right?
Oh, is it the mean?
Yes, X bar is the mean. Is it the mean of a population or is it the mean of a sample?
Population?
Try again.
A sample?
Yeah, this is a sample. It's the mean of a sample, right? That is a symbol for the statistic of a mean. The symbol for the mean, and Maddie, on this page here, it's here. What is the symbol for the mean of a population?
The U?
This thing right here?
Yes.
Yes, that's correct. Yeah, and it's actually supposed to be like an M. It's called mu. Mu.
Yeah.
I've shown you the cow picture, haven't I? Yeah.
No.
No?
Maybe I'm just not remembering.
The Greek I can't find it right now. The Greek cow going mu. No? Okay. All right. Let's ask some. This is a harder one. We're going to ask Virginia. What is this symbol?
Is that the critical error?
That is the critical. Wait. It's critical value, but that's very good. Critical. Yeah. You got the critical. That's good. That's the critical value. That's right. Very good. So Virginia, you're on a roll here. What does this represent? Or just tell me what the symbols are. What's this symbol here?
Sigma.
And what does it stand for?
Standard deviation.
Standard deviation of a sample or of a population?
Population.
That's right. That is a standard deviation of a population. And what about this symbol right here? What does that stand for?
Just sample size.
The sample size. Very good. Very good. Oh, we're rocking. Okay, so I'm not going to call on you again, Virginia, but Cassandra, what's this symbol?
Standard Oh wait, yes. Is it standard deviation?
Without the question mark, it's a standard deviation.
Standard deviation.
And is it of a population or of a sample?
Sample?
Without the question mark, you're right.
Sample.
Yeah, because this is the standard deviation of a population. The Greek letters are for the population. The well, what is this? What is our alphabet? Our alphabet has a name for it. What is it? Latin. There we go. Yeah, the Latin letter S. That's for standard deviation. And then we got this big thing right here. And well, let's see. Does anybody remember what that stands for? I'll take a volunteer. What does this stand for? Go for it, Ariel. What?
the standard error?
That is the standard error, right? SE standard error. Yeah, this is a standard error, and this particular standard error has a sub X bar. We might sometimes have a standard error with a sub P hat, but that would be for proportions and categorical variables, and this is for our quantitative variables. Okay, good. So you definitely want to. Well, we're going to run into all those symbols, so you just be aware of that. All right. So our first objective. Oh, well, I see our first objective is we need to practice social distancing and not everybody reach into the bowl of M&Ms at the same time, because then we're just passing the coronavirus around from one person to the other. So bad idea. Clearly a pre-coronavirus textbook. All right, so our objective 1, we're going to explain why the t distribution rather than the normal z distribution is needed to conduct inference for a population mean. So this guy, whose name I can't pronounce, Brian something, Wansink, he wrote a book called Mindless Eating. Now, there's a title, huh? Does anybody ever practice mindless eating? Yes. Let me phrase it differently. Does anybody never eat mindlessly? No. Yeah. I was at my mom's yesterday, and I think I told you that she has this unlimited supply of chocolate, and that's when I practice mindless eating. I just, go to the chocolate bowl, go to the chocolate bowl, go to the chocolate bowl. Yeah. So now that she's living back at home and not living in this assisted living place, I'm trying to visit her twice a week instead of like a little bit less frequently than I used to. And so now I'm just eating chocolate twice a week. It's mindless. All right. So he wrote a book that wanted to know what influenced people to eat without conscious regard for what they're eating. So he did a study that involved a sample of 20 undergraduates from the University of Illinois at Urbana-Champaign. And they were allowed to take as many M&M candies as they wished from a 24-ounce bowl. That's a pretty big bowl for consumption during a lab study session that day. And after they selected the M&Ms individually, the researcher determined how many M&Ms each person had selected. So this sounds like a great study, right? If you're the participant, because you get to reach into the bowl of M&Ms and take as many as you would like. So you are now the researcher, and you are going to offer a study session, and you want to offer the students M&Ms, and you've got to figure out, well, how many M&Ms do I need? So if you know about how many M&Ms a student tends to take on average, and you know how many students are coming to your study session, well, then you should be able to figure out about how many M&Ms you need. Does that make sense to everybody? Very, very, very practical problem to know how many M&Ms to buy. Personally, I just buy many more than I think that they'll need, and that way I can give a bunch of them away and I can eat a bunch myself. But that's maybe not so scientific. All right, so Magic Bowl is asking again. We are asking Emma, is the variable number of M&Ms selected, is it categorical or is it quantitative?
Categorical.
I say think again.
Quantitative.
Yeah, no. So can you think why that might be quantitative as opposed to categorical?
Because it has to do with like the population and like numbers.
Yeah, it's a number. We're counting something. We're not dealing with a proportion. We're not saying like how many blue M&Ms do people take or the what proportion of blue M&Ms there are. We're saying how many M&Ms do people take? We are looking for a quantitative number. We're not saying a lot, a medium amount, not that many. That would be categorical. but we're saying exactly how many M&Ms do people tend to take. Okay, so quantitative variable. Oh, and look, we have a dot plot of the results. So what this is telling me is that over here is Mr. Jankin. And does anybody end up down here? Anybody like really dislike M&Ms? Oh, Sitlali? Sitlali is down here.
I don't really dislike them. I'm just trying to like, I've been working out and I've been limiting myself on how much like junk food or greasy food or like candies I've been eating.
Good for you.
Yeah.
Good for you. All right. So so that's our that's our 99% confidence interval right there, you know. But yeah, I'm definitely on the outer boundary of that. So this is what the dot plot looked like, and this is the summary of statistics. So our n was 20, and it turned out that the mean was 50.15 with a standard deviation of 30.31. That's a large standard deviation relative to the mean and the number of M&Ms in total. I think that's a very large standard deviation. The minimum number taken was 7. The median was 42.5. The max was 111. And then they gave us Q1 and Q3. So we have a nice 5-number summary here as well. So we're going to ask, now we're going to ask Keely, are the numbers 50.15 and 30.31, are they parameters or are they statistics?
Parameters.
Try again.
Statistics.
Yeah, okay, now why? You know, on these binary ones, you know, you really only get one shot, you know. I mean,
They refer to the sample.
because they're from a sample. That's exactly right. They're from a sample. So these numbers here are statistics, and they're from a sample. So Keely, now you got to tell me, what is the symbol that I would use? What is the symbol I would use to represent 50.15?
Sigma.
No.
I don't know.
Okay, that's fine. Hang on. You will find out in a moment. We're gonna Virginia. You keep coming up. I'm not gonna call on you again. Sorry. Izzy, what symbol do I use to represent the 50.5?
I have no idea.
Okay, okay, well, hang in there. You'll find out in a minute here. No, I can't ask Keely again. Okay, Isabella, what do we got?
Is it mu?
No. Mu represents the mean, but this is, Keely just told us this is from a sample. It's not from the population.
X bar?
X bar. Right. I have these are the statistics that I got from my sample. So X bar represents the mean. And what about this 30.31? What is the symbol I'm going to use for that? Kaylin. Are you, yep, you're there. Are you there, Kaylin?
Yeah.
I can't hear you.
I'm not too sure.
Okay, hang on, you'll know. Clara, what symbol do I use for this 30.31? Clara,
If it's standard deviation, isn't that just S?
Indeed it is. It's just S. Yeah. So you see, you guys are gonna have to remember these symbols here. So X bar is the mean for a sample, and S is the standard deviation for a sample. And these are statistics because they came from a sample. So I will take a volunteer here. I need like a sentence that describes the parameter of this study. What is it that I'm looking for here? I need a sentence that describes it, and then the symbol that I would use for it. So what am I trying to find out here? Why am I even bothering doing this particular study? What is the parameter I am seeking? What am I trying to find by doing this study? I will take a volunteer. Okay, Ariel, you seem to be the most volunteering of the group here today, so go for it. What do you think?
You're trying to find the average amount of M&Ms a person would take, like one of the students.
That's exactly right. I'm trying to find out the average number of M&Ms that a person would take. Make sense? Yes? Okay, so what symbol do I use to designate that parameter? Yeah, Bella.
Is it pi?
No, pi would be a parameter if we were dealing with a proportion.
Is it p hat?
No, p hat would be the proportion if of a sample.
Oh, then I don't know.
You don't know? Well, Ariel just said we're trying to find the average number of M&Ms a person would take. Okay.
Is it that little? Is it the circle thing?
Nope. We're running out of symbols here, ladies. Running out of symbols. Yeah, Giselle, what is it?
Mu.
It's mu, right? Mu is the mean of a population. And we are trying to find the parameter that is for a population of the average number of M&Ms that a person would take if they were just have this nice bowl put right in front of them and they can take all the M&Ms that they want. So we're trying to find the mean of the population. So I'm gonna make a little diagram here. I had it written down for later, but I'm gonna put it right here now. So we start with a population, and from the population we take a sample. So the things that we use for sample is n, that's our sample size. And then from the sample, we get statistics. It's the SDAT. I spelled that. Come on, you can spell statistics, Glenn. STATISTICS. You get statistics. So from statistics, I either get like X bar or P hat, and I also get a standard deviation. Yeah, that would be for both of those. Right, that would be statistics. And then from the statistics, I infer my parameters. Because parameters apply to the population. And that would be the average mu, or the proportion pi, and then the sigma, the standard deviation. Parameters deal with populations. These are my P's. Statistics deal with my samples. These are my S's. I know, I kind of like this, the way this flows. Questions? Yeah, Bella, what?
Why does population flow into sample again?
Well, so I'm starting with a population of interest. I'm starting with, I want to know something about some population, right? Like I want to know the population of all students. And it's just way too big to measure, right? I mean, I could never get all students. There's too many of them. So I take a sample from the population, and that's where I'm going to get my numbers from. That makes sense? Okay, right. So just so we remember here, statistics and parameters, let's write this down here. Statistics and parameters are numbers. A mean is a number, a p-hat proportion is a number, a standard deviation is a number. A mu is a number, a pi is a number, a standard deviation is a number. These are numbers. And we get the numbers from the samples and we infer them to the population. Okay. Want me to email out that chart? You like that chart? Yeah, I'll email that chart out. Let's just, this is slide 12, file, export as, come on, PDF, full page, page 12. Stats chart. Okay, that'll get out to you guys. Okay, so nope, we're stopping. We're done. Happy Easter break. All right, you know, we'll see you tomorrow. If you have not yet sent me your weird thing, send me your weird thing. We're gonna have fun with the weird things. I have to say, some pretty weird things. Pretty weird things. Yeah, which is way cool. So, and I have a good song too. So we're just gonna be rocking tomorrow. So, all right, go take an extra long break. And how much early did we leave? Oh, we're good. You got a half an hour. All right, go chill out.
Thank you.
Thank
All right,
you.
good.
Thank you.
Thank you, Mr. Dingus.
All right,
Thank you.
later.
Thank you.
Thank you.
You're welcome.